Hey everyone. Today we're going to use a lot of the information that we talked about over the course of the last week to find other parts of the triangle. We're going to use our three original functions of sine, cosine, and tangent, along with their reciprocal functions of cosecant, secant, and cotangent to help find missing sides and missing angles of these triangles. Now, just like I've stressed over the last week, it's going to depend on what angle we're looking at and what information is given to us, whether it is a side, an angle, or what other missing piece. The two essential questions for today are which type of trig functions can be used to calculate unknown angles in a right triangle, and which type of trig functions can be used to calculate unknown sides in a right triangle. As we go through here, I'm going to keep referencing these two main questions, just so we can all kind of keep in our minds the type of angles to use or the type of functions to use when looking for an angle, and the type of function to use when looking for a side. Here we go. Now here we have the familiar slide where we have all six trig functions: sine, cosine, and tangent, cosecant, secant, and cotangent. Now to form these six ratios, it all depended on what sides you had of a triangle: opposite, adjacent, or hypotenuse. But to understand what ones were opposite, adjacent, and hypotenuse, it all depended on what angle theta we were given. Now if the theta was down in this lower left corner, obviously the side opposite would be here and my adjacent's here. But if I moved my theta up here to the top right corner, then that would switch my opposite and adjacent sides. My hypotenuse is always the side across from my 90-degree angle. Now, understanding basically what pieces of the triangle you're given, based on what angle you have, will help determine what three of these functions you may use. This may make more sense when you see the first example, but remember, everything is going to come down to perspective and what information you're given in the original problem. Now, every single problem we've had so far has dealt with exactly finding the ratios, whether it's the three original or the three reciprocal. Now, all of a sudden, we're going to use those six functions to find either angles or sides of a triangle. But again, like I said on the previous screen, it's going to come down to perspective and what is actually given to us in each problem. So here we go. The goal here is to find the value of x. So x is here. Now x is my hypotenuse. So at least I can identify that this right here is my hypotenuse. Now what else is given to us? Well, I'm looking over here at this angle of 38 degrees, and I'm looking here at this side of 5. All right, so I can see that this angle is where I'm going to focus my attention. Now, what two sides of the triangle do I have from here? Well, instead of trying to reinvent the wheel, just go back and relabel the sides like you're used to doing. This is going to be your theta. So from this angle, I know that this side 5 is my opposite, and I know that this missing side over here, which doesn't have a value, is my adjacent. So using the information that you're given, and only the information that you're given, we're going to be able to fill in these ratios. It's going to take our knowledge of what trig function we're given based on the information in this problem to set this problem up. So here I have my angle, I know my opposite, and I'm looking for my hypotenuse. Notice there was no value where this adjacent side was, so I don't care about it. I labeled it just so I can have it on, just so I can see exactly what it is, but notice there's no value there. And the value of x that I'm looking for is over here. So the only pieces of the puzzle from this angle that I'm given are my opposite and hypotenuse. Now, which trig function uses opposite and hypotenuse? It's my sine function. So I have my sine function equals opposite of hypotenuse. What I'm going to do is I'm going to take my values that I have in this triangle and plug them into this function. Now, I'm going to read it from left to right. Sometimes I will be given an angle, sometimes I won't be given an angle. So my sine of 38 degrees, well, I know my theta value is given to me, so that's something I can fill in. Now, as for my ratio, do I know my opposite side given to me? I certainly do, so I can fill that 5 value in. Next, my hypotenuse. Do I know my hypotenuse? Well, no, I don't, and that's my value of x of what I'm going to try and solve for. So all of a sudden, what I have formed here is the sine of 38 equals 5 over x. We used our knowledge of trig functions, in this case the original 3, to set up a proportion or to set up this equation. Now I call it a proportion because that's exactly what it is. Technically, it's sine of 38 over 1 equals 5 over x. So you're going to multiply the denominator of one side by the numerator of the other, and the denominator of this side by the numerator of this side. You create kind of a loop. So if I take this 1 times this 5, what I get is a 5. And if I take this x times the sine of 38, well, I get x times the sine of 38 degrees. Next, to get this x by itself, I'm just going to divide by the sine of 38 degrees. So my value is x equals 5 over the sine of 38 degrees. Now this would be a final answer, except if I said that this missing side of my hypotenuse is 5 over the sine of 38, that wouldn't make much sense. So what we're going to do is use our calculators. What I have here is a little bit of an image or a screen capture of a standard Casio calculator. And I'm going to talk you through the keystrokes here of how to figure out what the 5 divided by the sine of 38 actually is. On your calculator, you would hit 5, then divided by the sine button sitting right here. Then you'd hit 38. And when you hit equals, or you can close your parenthesis at that point and hit equals, you should get an answer of about 8.1213462, dot, dot, dot. Now, obviously, I'm not going to list this value as this crazy looking decimal for my side of my hypotenuse, so I'm going to round off to the nearest hundredth, or the second decimal place. So our final answer of this missing side is 8.12 units. Now I'm going to compare this. The only side that I know is this 5, and you know your hypotenuse has to be the largest side of a triangle, so as long as this hypotenuse is longer than the side that you're given, you know you have a puncher's chance of being correct for this problem. Now, 8.12 might not be the answer that everyone gets. A few things to keep in mind. On your calculators, there should be the value D here, which stands for degrees. Your calculators, whether it's a Texas Instrument, a Casio, or anything else, have the capabilities of calculating values of radians or degrees. In this case, I have my D value here for degrees because I'm using degrees. So that will make a drastic difference in your calculations as you plug them in if you leave your calculator in radians. Now, 8.12 is not the only answer you can get. There's a variation of the answers you're going to be able to get, and I'm going to show that here. And then I'm going to explain the differences between the two. Now, a real quick explanation of what I did. I still set up my function as the sine equals opposite of our hypotenuse. I still plugged my values in based off what I was given. So the 38 degrees I knew, and my opposite side I knew. I still cross multiply to get x times the sine of 38 degrees equals 5. But the difference here is I used my calculator to get rid of this trig function early. Now, whether you get rid of the trig function early, and I punched in my calculator, the sine of 38 degrees is 0.62. So sometimes for students, when you're looking at these problems to start, you may think that getting rid of the trig function when you can earlier than saving it for the very end might make these problems a little more clear and a little more connected back to Algebra 1. So I divide both sides by 0.62, just like I divided both sides by the sine of 38, and I get 8.06 as my answer. Now I said earlier that 8.12 is not the only answer you can get. But both of these answers are correct. Depending on how you want to round, or depending on how you want to solve these problems, 8.06 or 8.12 are completely correct. If you had an answer of 8.12 and 13.47, then those answers are nowhere near each other. So as you think through and looking for the side of a triangle, the type of function that you use is a standard or original trig function. And also, if you give or take about a half of unit, so anywhere from like 8.12, 8.5, 7.5 in either direction, those would be considered correct for me, only because of rounding as you go through the problem. Whichever method you prefer, please feel free to use. Now, before we go through the next problem, I want to do a real quick review. My goal for this year is anytime we introduce a newer topic, I'm always going to try to connect it back to something that we were taught in the past or you learned in the past. So if I gave you an example, like x to the second equals 25, and I asked you to solve for this particular value of x. Again, we're solving for this value of x. How would you do it? How would you get x by itself? Hopefully most of you sat there and thought, oh, I would take the square root of both sides, and I would go get the x equals 5, if I can draw 5, as my value. Now technically it's a plus or minus, I'm not going to get into that again right now, but nonetheless, in order to get rid of this square term, or to get rid of this particular part of this x squared function, you took the square root of both sides and it canceled it out. So you performed a function to eliminate or to clean up another function. And this old school example of finding square roots will hopefully help connect some of the questions that you may have when trying to solve for, in this particular case, the x that you're going to see here as an angle. Just because my numbers change doesn't mean my math changes. I still use the original three functions, or the reciprocal functions if you choose to. I'm going to stick to the original three, based off what I'm given to set up these ratios. So let me go through and start to set up this problem. I know, just like the last problem, since I'm looking for a value of x here, this x is going to be determined, or this function ratio that I'm going to use is going to be determined off what I'm given. So from this angle, this is now my angle of where I'm keeping all of my attention. So what sides of the triangle am I given along with this particular angle? Well, I know I'm given my opposite side, and I know from this angle x, I know I also have my adjacent. Now, the one side of the triangle I do not have, and there's no value there, is my hypotenuse. So that makes things easier for me. All I care about at this point is choosing the correct trig function to set up my ratio to go through and do all of my work. Well, here's my angle. I know I have opposite, and I have adjacent. So that tells me that I know I have the tangent of theta equals opposite over adjacent. Personally, I think identifying what ratio you have is the most difficult part to these problems. The very first lesson I said, if you're able to determine the sides of a triangle based on what angle you're looking at, the perspective where I drew that little stick figure, if you can get beyond that, the rest is just algebra or arithmetic. So here we go. I have no clue what I'm going to solve for in this problem yet, besides the value x, but I'm going to plug in my values that I know into this ratio again, just like I did in the previous problem. So I know I have the tangent of theta equals opposite over adjacent. I'm going to read it from left to right. The tangent of theta. Do I know my theta? In this case, I do not. In the last problem, I was able to fill in 38 degrees. Well, right now I'm not, so I'm going to keep this as the tangent of x equals. Well, do I know my opposite? I sure do, because I labeled it in the beginning and I got that pain out of the way. So I have a value of 12. Do I know my adjacent? I sure do, because I labeled it in the beginning. Again, identifying the three sides of your triangle, that will be the most difficult part to these problems for many of you. So I know that my adjacent side here is 17. Now, the tough part. All of a sudden, I can't cross multiply and solve here because there is nothing really for me to actually go through and solve for. 17 times I can't divide by much. So what I have here is this ratio of 12 over 17. And here's where the idea of what we talked about in the beginning of solving for this x by taking the square root of both sides comes into play. This x had a square root attached to it, and we had to somehow magically remove it by doing this operation of taking the square root of both sides. Now, without getting into too much, this was taking a function of another function, or using what are called inverse functions in order to cancel these terms out. Well, if you take a look here at your calculators, you'll see that you have, there we go, you'll see that you have a whole row of your original three functions, the sine, the cosine, and the tangent. And then in the lighter yellowish or orangish color here, you'll see it has a sine to the negative first, cosine to the negative first, tangent to the negative first. These are called inverse trig functions, and you get to them by hitting this shift key. Now, if it's a different calculator, the inverse functions of sine, cosine, and tangent should all still be in the same location, but it may be a second type function. What I'm going to do is show the notation of what this looks like, and then come back and explain what it looks like on the calculator in order to get the correct answer. Now, what I've done here so far is I've taken the inverse tangent of both sides. I wouldn't take the inverse cosine or the inverse sine of both sides since I'm dealing with tangent. The only time I would use inverse sine is if my original ratio was sine. I would take inverse cosine if my original ratio was cosine. So you take the inverse of both sides. Exactly the same thing what I did up here. I took the square root of both sides to cancel out that 2, that exponent. And what I was left with was just an x equals some number. The reason why I take my time on this part of the problem is because of the lesson we did last week, where you have the three most confused and misused words in all of math: opposite, inverse, and reciprocal. Notice I haven't mentioned cosecant, secant, or cotangent anywhere in this lesson. Why? Because I'm trying to go through and use what are called inverse trig functions, which again are located above the three buttons of your calculator, to solve. When you use the inverse functions, the tangent and tangent go away, leaving you with the goal, the end result you were hoping for of x equals, or the x by itself, just like it was up here, x equals the inverse tangent of 12 over 17. Well, guess what? X is by itself, we're done. But again, if I listed this angle as the inverse tangent of 12 over 17 degrees, you'd think I was crazy. You'd say, Mr. Shook, what number is that? Well, lucky for us, we have these wonderful calculators. And these wonderful calculators here will allow us to punch in exactly what we see to get a decimal. So you'll hit Shift, Tangent. The left parenthesis should automatically appear. 12 divided by 17. Close your parenthesis, hit equals, and you'll get an answer of, if I round it off, 35.22 degrees. So what does that mean? It means that this angle here, x, is 35.22 degrees. Does it appear like this angle x is 35.22 degrees? I'd say so. Now, so to kind of think back to the original slide here, when you're trying to find the angle of a particular triangle, what type of functions used? Well, yeah, I used an original function to set everything up, but it was essentially or finally this inverse function that I was able to use to find the value of x for this particular angle measure. So to kind of recap today's lesson, what type of trig function can be used to calculate unknown angles in a triangle? Well, remember, when we don't know the angle, we know both sides, which means we have to use an inverse function. So anytime you're looking for the angle of a triangle, you always use an inverse trig function. It's either the sine, the cosine, or the tangent inverses based on the original ratio given to you. Now, which type of function can be used to calculate unknown sides of a triangle? That's when we move back to the very first example, and it was a standard or original trig function. Hope you guys enjoyed.